This is a video showing you how to do each problem in the Chapter 3 review. Problems 1 through 5 give you a diagram and ask you to identify the appropriate angle given lines F and G are parallel. So if I want corresponding angles, remember corresponding, you kind of imagine your diagram's cut into two parts. If you look at 2, angle 2 is the top right of its little group of 4. The top right for the other group would be angle 6. Alternate interior with angle 4, so here's angle 4. This is the interior. Alternate means on the opposite side of the transversal, so it would be angle 5. Alternate exterior with 1, so here's angle 1. Remember, out here and here is the exterior. Alternate means opposite sides of the transversal, so that would be angle 8. Same side interior with 2, so here's angle 2. Remember, this is the interior. Same side of the transversal would be angle 5. Lastly, vertical with 8. Remember, vertical has an intersection. So we're looking at this intersection here. For them to be vertical, they're non-adjacent, so they're actually kind of across from each other. So that's angle 5. For 6 and 7, we're solving for the indicated value. The first thing we want to do is identify what type of angle pair they are. So if I look at 6, these two angles are same side interior, which means they're supplementary, so they add up to be 180. So I would take 180 minus 120, which gives me 60, so x is 60 degrees. For number 7, I again want to look at my angle pairs, so I have these two angles. These are alternate exterior angles, and we know that alternate exterior angles are congruent. So if this angle is 135, W is also 135. We're still solving for x, and we still want to start by looking at what type of angle pairs we have. If we focus on these two angles, these angles are corresponding angles. We know corresponding angles are congruent, which means their measures are equal, so we want to set these two equations equal. I would subtract 11x from both sides. And then I would subtract 3 from both sides. X equals 6. Again, number 9, I want to look at the angle relationship. So these two are same side interior. Same side interior angles are supplementary, which means that they're going to add up to be 180 degrees. So x plus 75 plus x plus 125 equals 180. We combine like terms, so I have x plus x, that's 2x. 75 plus 125 is 200 equals 180. Subtract 200 from both sides. 2x equals negative 20. Divide by 2. X equals negative 10. Problems 10 and 11 deal with slopes and equations of lines. So problem number 10 says find the slope of the line represented by the points -2, 3, and 6, -1. The first thing we need to remember is the slope formula, which you'll need to memorize, and it is y2 minus y1 over x2 minus x1. We label our points x1, y1, x2, y2, and then we're just plugging into our formula. So -1 minus 3, 6 minus -2. 1 minus 3 is -4. 6 minus -2 is really like addition, and it becomes 8. -4 divided by 8 is the same as -1/2. The second problem, so number 11, says find the slope of the line represented by y equals 4x minus 2. Remember, in slope-intercept form, we have y equals mx plus b. M is our slope. B is our y-intercept. If you look at the equation, the slope of this equation is 4. Now we're going to move to writing equations of lines. Number 12 says write the equation of the line with a slope of negative 1/4 and a y-intercept of 3. Again, slope-intercept form is y equals mx plus b. M is slope, b is y-intercept, so I'm just taking those values and plugging them into the appropriate spot. So y equals negative 1/4 x plus 3. Number 13 says, write the equation of the line represented by the points 3, 1 and negative 4, 15. This is going to take multiple steps, so first thing I need to do is I need to find my slope. So remember, we do that by labeling our points x1, y1, x2, y2, and using the slope formula. The slope formula is y2 minus y1 over x2 minus x1. When I plug in, I have 15 minus 1 over negative 4 minus 3. 15 minus 1 is 14. Negative 4 minus 3 is negative 7. 14 divided by negative 7 is negative 2. So I have a slope of negative 2. The next thing I need to do is pick a point and then plug in x, y, and m. I'm going to use the point 3, 1. You could also use the other point. It really doesn't make a difference. So I have x, I have y. We just figured out m is negative 2. I'm going to plug all of those in to y equals mx plus b. So that would look like 1 equals negative 2 times 3 plus b. And now I want to solve for m. So negative 2 times 3 is negative 6 plus b. Add 6 to both sides. B is 7. The last thing we want to do is we want to rewrite. We're only going to plug in m and b this time. So y equals negative 2x plus 7. Number 14, we're going to use the reasons listed below and statements to fill in the proof. It says, given M is parallel to N and the transversal P, prove that angle 2 is congruent to angle 7. Remember, if this stuff was not filled in, the statement they give you always goes in the first box. The first reason is always given, which we can see as letter L. Now, there's a slight typo right here. This should say 2 is congruent to 7, so we'll go ahead and fix that. Remember, whatever they ask you to prove always goes in the very last statement box. However, we don't ever use prove as a reason. Notice that in my final statement, it talks about angle 2 and angle 7. So I'm going to look for reasons and statements that will use those two angles. So the first one I see is this 2 is congruent to 5. So if I go up to my diagram and I look, is 2 congruent to 5, and if so, how? Yes, that's actually true, and it's true because they're corresponding angles. So I'm going to fill in that choice B, 2 is congruent to 5, because H, they're corresponding angles. Now, I've used the 2 part here, so now I'm going to look for something that involves angle 7, and I'm seeing that angle 5 is congruent to angle 7, so I'm going to look and see if that's true. So here's 5, here's 7, it is true, so D, angle 5 is congruent to angle 7, and those are vertical angles. So G, vertical angle theorem. Lastly, I need to just figure out the reason for the last statement. So if I read the previous three to you, I have 2 is congruent to 5, 5 is congruent to 7, 2 is congruent to 7. Hopefully that sounds really familiar, like A equals B, B equals C, then A equals C. And remember, we call this the transitive property. So I would choose I. For problem 15, we're just finding the measurement of all these different missing angles. There is no right or wrong way to start this. Just some things to point out to you. Notice that there are parallel lines. So these two are parallel to each other with lots of different transversals. And then these two are also parallel to each other, again, with a lot of different transversals. Just because I do this problem a certain way doesn't make it right or wrong. There's several different ways to start, and we should still get the same answers, so hopefully we do. The first angle I notice is just 62, so I'm going to start in this area over here. So I see that 62 and G are vertical, so I know that G is also 62 degrees. The next thing I notice is that 62 and F are a linear pair, which means that they add up to be 180 degrees. So if I take 180 minus 62, I get 118. So angle F is 118. The next thing I notice is because these lines here are parallel and I have a transversal, these angles, 62 and H, are corresponding. So H would also be 62. This angle is marked congruent to 62, so I'm going to go ahead and fill that in, even though it doesn't say that I have to solve for it. Because then what I notice next is I have a triangle right here, and I have 2 of the 3 angles filled in. We know from triangle angle sum theorem that triangles always add up to be 180 degrees. So currently I have 28 plus 62, which is 90. And 180 minus 90 is 90, so angle E is 90. If I continue working my way across, the next thing I notice is A and 28 are a linear pair. Again, linear pairs add up to be 180, so if I take 180 minus 28, I get 152 degrees, so A is 152 degrees. I also notice that 28 and B are vertical, and vertical angles are congruent, so angle B is 28 degrees. The next thing I notice is that if I focus on these 2 parallel lines and this transversal, angle A and angle C are corresponding. So if A is 152 degrees, so is angle C. Then you should notice that C and J are vertical. So if C is 152 degrees, so is angle J. Now to find the measure of angle D, I'm going to use these 2 parallel lines and this transversal. So if you look, I can see that angle D and this other angle that's marked congruent is corresponding to angle A. So we know corresponding angles are congruent, and angle A we had was 152 degrees. So this entire angle is 152 degrees. However, I don't want the entire angle. I want just this piece. And if you look, these are marked congruent, so we know they're the exact same. So I'm really splitting 152 in half, or dividing it by 2. When I split that in 2, I should get 76 degrees.